Again, happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so yesterday we looked at factoring trinomials where the leading coefficient was not a 1, and we used the grouping method. Today we're going to continue looking at that same idea, only we're going to use a method that this particular author calls trial and check. I've heard it called guess and check, trial and check, the FOIL method. Anyway, but it's different from the grouping method, as we will see. So let's go ahead and get started. All right, here. So let's take a look at a problem, which is 3x squared plus 4x plus 1. So to use this method, we still want a trinomial in standard form, descending powers of the variable. If there's any greatest common factor, we want to remove it. If the leading coefficient is negative, we want to factor out a negative. We want to do all of that first. In this case, it's good to go. So now we take a look at the leading coefficient, the 3, and we write all factor pairs that multiply together give us 3. In this case, just 3 and 1. Then we look at the constant term at the far right, and we write all factor pairs that give us 1, okay? Since the middle term is positive and the final term is positive, we're only going to have positive numbers. Now, what we do next is we take these numbers and we put them at the front of two binomials. We take these numbers and we put them at the rear of the two binomials. In this case, since there's only one pair here and these two numbers are identical, this is the only possibility. So 3x plus 1 times x plus 1 would be the final answer. So in this case, factoring it this way is fairly simple because there's only one possibility. Again, checking our work, 3x squared plus 3x plus 1x plus 1. Combining like terms, 3x squared plus 4x plus 1. So it checks. All right. Now let's take a look at another problem. This one is 15a squared minus 28a plus 5. Again, we have a trinomial. It's in standard form, descending powers of the variable. There's no greatest common factor. The leading coefficient is not negative, but it's also not a 1. So we're going to create all the factor pairs of 50 that give us 15 as a product. So 15 and 1, 5 and 3. Okay. Then at the far end, we've got a 5. So we want factor pairs that give us 5. We've got 5 and 1. But the middle term is negative. Well, 5 is positive, so it has to be positive times positive or negative times negative, okay? But to get a negative middle term, we couldn't have positive times positive. So basically, we've got those possibilities, all right? Now, I'm going to write out the possible factor pairs, 15a and 1a, okay? And then minus 5 and minus 1. Let's go ahead and get rid of that 1 there because we don't need it. But it could also be 15a and 1a and minus 1 and minus 5. These could be reversed, okay? My a's look like 9s. But then it could also be 5a using this and 3a and minus 5 and minus 1, or it could be 5a and 3a and minus 1 and minus 5. So it's got to be one of these times one of those. and the other of those times the other of those, or one of these times the other and the other times the ones. In other words, all the different combinations. Okay. So there's what? 4 possibilities. All of these, if I FOIL them out, I'm going to get 15a squared at the front and plus 5 at the end. But the one I want is the one that gives me minus 28a in the middle. Where does that come from? It comes from the outer and the inner. Well, let's see. This would be minus 15a minus 5a is minus 20a. That's not it. Minus 75a minus 1a is minus 76a. That's not it. Minus 5a minus 15a is minus 20a. That's not it. Minus 25a minus 3a. That's it. So here is the correct answer. Now, it happened to be the last one. I didn't deliberately set it up that way. It's just using all the combinations. That was the one that worked out. Okay. Now, writing all these out can get rather tedious. And so, in fact, we'll do some more and see that. So we'll talk about sort of shortcutting the system here in just a bit, but not quite yet. Let's see here. We've got 4b squared plus 15bc minus 4c squared. 4 could be 4 and 1 or 2 and 2. Negative 4 could be negative 4 and 1, negative 1 and 4, negative 2 and 2, and then 2 and negative 2. Actually, this one and this one are the same, so I don't need to list both of those. Okay. Again, any question about where I'm getting those pairs of numbers? So now let's consider all the possibilities. We could have 4b and 1b and minus 4c and plus 1c. So that's putting this with this. But we could also have 4b and b and then plus c and minus 4c. That's also putting this with this, but I've switched these two numbers around. Okay. But we could also have 4b and b with this group, which would be plus 4c and let's see here. Got lost here. Minus c. Or I could have 4b and b, and it would be minus c and plus 4c. So again, I'm taking one of these with one of those, the other with the other, and then switching them, one of these with the other, et cetera, to see what's happening there. Okay. But then it could be this group with this group. So it could be 4b, b, and minus 2 plus 2. Or it could be 4b. Oh, what have I left off? I left off the c's here. 4b plus 2c, b minus 2c. So I've got 6 possibilities, but I'm not done yet. Because what about this with all of those instead? Well, this would be 2b minus 4c plus 1c. Since these are the same, switching these around wouldn't make anything different. So then I've got this with this, which is 2b minus 1c plus 4c. And then 2b, minus 2c plus 2c. I think that's all of them. Let's see, 6, 7, 8, 9. Yep. So those are all the possibilities, okay, that give me 4b squared up front and minus 4c squared at the end, okay? But we're looking for the one that gives us a positive 15bc in the middle. Let's see, this is going to be plus 4bc minus 4bc would be 0bc. This would be minus 16 BC plus 1 BC would be minus 15. Ooh, right number, wrong sign. This would be minus 4 BC plus 4 BC. That's going to cancel. This is what? 16 BC minus 1. Oh, there we go, right there. Now, I didn't do this because I could show you, I wanted to show you all the different possibilities. But what I could have done is I could have checked each one as I wrote it, and then I wouldn't have had to do all of these because I would have discovered that this one was the correct answer. Let's check our work on that. That's 4b squared plus 16bc minus 1bc minus 4c squared, 4b squared plus 15bc minus 4c squared, and it checks. So there's our answer. Now, doing it this way is awful. There's got to be an easier way to do this method, and there is. And here's where you kind of end up deciding which method you like. The other method, the grouping method, does have a lot of writing because you have to, sometimes you have to look for those two numbers. It takes a while to get there, okay? This method, doing it the way I did it, writing it all out, is going to take a long time as well. So let's take a look at how we could speed up this method. Let's see here, 4b squared plus 15bc minus 4c squared. And this was 4 and 1, 2 and 2, negative 4 and 1, negative 1 and 4, negative 2 and 2. So the mechanics of the problem, let's go back here. When I'm looking at this combination with this combination, the 4 and the 1 and the negative 4 and the 1, what do? I put the 4 here and the 1, or the 4b and the 1b there, and then the minus 4c and the plus 1c, okay? And then I take this again, the 4b and the plus b, and I switch these around and put the plus 1 and the minus 4. So I'm taking one of these with one of those, plus the other of those with the other of those, and then switching them around, okay? So let's see. What's 4 times negative 4? It's negative 16. What's 1 times 1? It's 1. What's negative 16 plus 1? It's negative 15, but I want positive 15, okay? So what if I switch these around and I go, what's 4 times 1? That's 4. What's 1 times negative 4? That's negative 4. 4 plus negative 4 is 0. So this combination with this combination doesn't work. But unfortunately, I can't get rid of either one. I can't get rid of the first group because it might go with one of these. I can't get rid of this because it might go with this one. So now, oops, erased too much there. I'm going to take this one with this one. What's 4 times negative 1? It's negative 4. What's 1 times 4? It's 4. What's negative 4 plus 4? It's 0. Okay. What's 4 times 4? It's 16. What's 1 times negative 1? It's negative 1. What's 16 plus negative 1? It's 15. Aha! So what does that tell us? I need a 4b and a 1b, and I need a minus 1 and a plus 4. But let's see, the 4 has to get multiplied by the 4 over there, so it's got to be here in the 4c and the minus 1c there, okay? Because the way it gets multiplied out, so there's your 16 BC minus 1 BC is 15 BC. Now, that's still a little complicated. You got to keep track of things, but it's a lot less writing than that. So what do you think? Do you like this method or not?
Yes, way better.
Oh, okay. Well, good for you. Good for you. What I find usually in a class of about 30 students, I'll have about 3 or 4 that like this one, and everybody else wants to do it the other way. And the reason for that is if you can see doing it this way without writing it all out, you're going to prefer this method. If you're one of those people who's like, I got to see what's going on, you're probably going to prefer the other method. Okay. All right, let's take a look at some more examples here. Let's see here. 16r minus 40r squared plus 25r cubed. So I've got to put it in standard form. I'm going to factor out an r. So now I've got what, 25 and 1, 5 and 5. Let's see, my final term is positive, my middle term is negative, so it's going to be negative 16 and negative 1, negative 8, negative 2, negative 4, and negative 4. Okay. So what am I looking for? I'm looking for minus 40 in the middle. And you know what? It's right here because there's minus 20, minus 20. Now, I just jumped to the finish line because I could kind of quickly do my calculations looking for, you know, instead of taking each individual one, that's negative 80, that's minus 1, that's negative 81, 25 times negative 1, that's negative 25, 1 times negative 16 is negative 16, negative 25, negative 16 is negative 41. Oh, missed it by that much. You know, so again, if you can see what's going on with the numbers fairly quickly, this method is awesome. Okay. And as I recall, because I did some of these same problems the grouping way yesterday. So here's your answers. Okay. Now, I personally don't care which method you use. You got to know one of them. For me, if the problem's quick and easy, like the first one I did here, I would definitely use this trial and check method because there's really only one possibility. But if it's something like this one, where there's a lot of possibilities, I might do it this way. I might do it the grouping way. Maybe it just depends on what mood I'm in. Okay. Now, oh, let's look at one more example here. 10u squared minus 13u minus 6. So I've got 10 and 1, 5 and 2, minus 6 and 1, 6 and minus 1, minus 3 and 2, minus 2 and 3. Okay. I'm looking for a combination that gives me negative 13. And this is where, if you could see my hand on the whiteboard, it would make things so much easier. But I'm going, let's see, 10 times negative 6 is negative 60. 1 times 1 is 1. Negative 60 plus 1 is not negative 13. Okay. 10 times 1 is 10. 1 times negative 6 is negative 6. 10 plus negative 6 is 4. So that's not the combination either. 10 times 6 is 60. 1 times negative 1 is negative 1. 60 plus negative 1 is 59. It's not that combination. 10 times negative 1 is negative 10. 1 times 6 is 6. Negative 10 plus 6 is negative 4. And as you can see, by going from here to here, it's not going to work. I'm just going to switch the signs. So you might argue, well, that was a waste of time. But anyway, all right, let's take a look at 10 and negative 3 is, or times negative 3 is 30. 1 times 2 is 2. Negative 30 plus 2 is negative 28. That doesn't work. 10 times 2 is 20. 1 times negative 3 is negative 3. 20 plus negative 3 is 17. That doesn't work. Ten times negative 2 is going to be negative 20. 1 times 3 is going to be 3. Negative 20 plus 3 is negative 17. 10 times 3 is 30. oops. One times 2 is -2. We get +20. None of those are working. Okay, so now at least I know that this isn't one of the possibilities. Okay, so it's got to be the 5 and the 2. And again, it would be much easier if you could see what I'm doing instead of, yeah, whatever. Okay, I wouldn't need to use all these circles, because if I point to something, you don't know that I pointed to it. All right, 5 times -6 is going to be -30. 2 times 1 is 2, -30 plus 2 is -28. 5 times 1 is 5. 2 times -6 is -12. 5 plus -12 is -7. And if we use these same ones, we come up with what? We get the 7 and the 30, but we don't come towards 13. Anyway, I'm going to stop here, because if I keep going and try all these other ones, I'm going to find that none of them work. So it's prime, but I'd have to check each possibility. Okay, so here's a case where, shoot, I have to try what, 1, 2, 3, 4, 5, 6, 7, 8, 9, a whole bunch of possibilities to make darn sure it isn't prime. So this one, maybe if I'd used the grouping method, I would have gotten there quicker. It's hard to know. Ideally, I would think you'd want to master both methods, but for now, pick one, stick with it, learn it well, and then if you want to expand your methods, to a different one, you can. Now, here's what I want you to do for the assignment over the weekend. WebAssign won't know how you do it, so you could do it either way and write your answer, but I really want you to do this method over the weekend so that you can be sure which method you prefer. Because just seeing a couple of examples, for instance, Antonia, you were like, yeah, I like this method better. Abel didn't say anything, so maybe he didn't like it. Maybe over the weekend you'll switch. Maybe Abel will try a bunch of these and go, oh, I like this better. And Antonia will be like, now that I'm doing it, I don't know. But so over the weekend, do the, it's another set of problems from 6.3, but using the trial and check method. And then on Monday, I'll poll the both of you or whoever else shows up, which method did you prefer? And then moving forward, you can use either one. Okay. Abel, did you have something you wanted to say?
Yes. This is still the same as A times C, correct? The one we did yesterday, like the A times C, and then we get the sum as well.
No. This is not at all doing it that way.
Okay.
Yeah, go back and watch this again later. Yeah, it's a whole different way of breaking things down here and then doing combinations. I mean, the result is the same, but the process you go through is quite different.
Okay, but it'll still give you the same exact answer.
Yes.
Okay.
Yeah, just a different way of writing. And there's something called the box method. I'm not going to get into that, but just, and then later we're going to use a formula to do this, but that's later.
Okay.
Anyway, I'm going to go ahead and stop the video.